explained, right? So we'll try to run one experiment, and afterwards we'll continue with the Linux and NS2 installation tomorrow, so that we can do the experiments.
Sir, and one more thing. If we ignore the power constraint, we can use it as a replacement for, we can use it as a permanent solution for ad hoc network. Can you use it for?
We cannot be able to use it because the power consumption of Wi-Fi is very high.
Okay.
If you want to use it, the battery will get drained within few minutes. Right? The maximum the battery can drive is 10 minutes or 20 minutes or 30 minutes. There are different batteries. But the problem is, as you increase the time, the weight of the battery increases. Right? And it might not be able to sit on the drone. Right? For example, I could ask you to put that car battery into that drone, you might not be able to carry it. Right? We want the size of the battery should be as small as possible so that the drone can lift it. If the drone have heavy weight, it consumes a lot of energy for lifting it up. Right? So it is not a feasible solution for drones. Okay? But what we can do is we can have a small Wi-Fi agent over there which can communicate among the devices and give you information. Not a heavy Wi-Fi, low energy small Wi-Fi you can have, which can communicate among themselves and transfer. And instead of that, Bluetooth is sufficient for doing that, same distance. Right? And it can connect up to 78 devices, which is sufficient for mass spec. Rest of things you can have wired communication also. Right? If the Arduino is there, you have a Ethernet cable port also, USB also. So you can communicate among all the devices. Right? You don't need a wireless service over there.
Yes.
Okay? Because wireless services are uncertain compared to wired communication. So there are other options also available, but for a long distance it is not so good. For internal communication you can still have it. And to have it you can have Bluetooth, which is less power consuming than Wi-Fi. Right?
We'll do the next session, and now we'll be doing small experiments on the SCI Lab platform. And SCI Lab is an open source software which is equivalent to the MATLAB, which have all the functions built in.
For libraries, and it can be used for linear algebra. It has sparse matrix, polynomials and rational functions also built into it. And you have signal processing as toolbox which can convert and transform data. Graphics interface is there for plotting, user interface and across environment. Optimization includes differential equation solver, linear matrix, inequality solutions. And dynamic compilations can link other languages such as Fortran and C. And this was developed long back. And recently there is a Python edition is also available in SCI Lab. Okay? And you have the numerical algorithms like scientific computing problems. Functions also, there are some functions built in. And libraries also, there are some functional libraries. So when you try to compare with the MATLAB, all the features might not be there. But for a small functionalities, this can be used. And the code also is similar, like MATLAB, what you write, the same code can be run on SCI Lab also. So you need not have to spend much time in learning about SCI Lab. You can directly use it. You can directly use it, but please remember that not all the toolboxes which are existing in MATLAB is available. And hence it is not that popular as MATLAB because the functionalities in MATLAB is added advantage. They have a lot of functions which can be given it. So with this small introduction about SCI Lab, we are going to give you a set of experiments in SCI Lab, but we only run one command and show you how to use it for the execution of satellite link. Okay? So we start with that directly, assuming that the other routines you have run it, but we provide you the list of experiments. You can just run those programs afterwards. And basically we'll try to take one experiment and we'll try to explain what we are trying to do it. Okay, I am handovering the mic to Meghana. top code, if you try to see, the top code, if you try to see, this is to generate the front end. Like we want to create a front end where you can insert the data and you can get the output and so on. So we call it a user interface. So this code is to generate only the user interface. It has nothing to do with your coding, right? So can you run it once? So if you run that one, you can see that we get a good screen over here. For generating this only, we are trying to write that. Okay, so that the user can enter his data and he can get the data output, right? So this front end is not MATLAB. We are generating that using some set of commands, this front end, so that the data from here can be passed down to the code. We call it a user interface, right? So here you can change colors, you can increase the style, decrease the style, boxes you can change it, everything you can change it, and you go back to the screen. And so here you have, so you can see that we have defined the handlers left to right, what should be the diameter, and all these commands are only for generating the user interface. Okay, so this can be modified. You can change these parameters to your requirement, whatever is you feel. You can put your name, or you can put your college name, and you can have whatever you want. You can just type it on that, right? Okay. Next, going to the code, if you try to see, from the handlers we are taking the data, right? And we are trying to compute you can see that you have 20 log TP into AGT, which will tell you the path loss. Okay, the path loss exponent you can calculate, and then you can feed it and you can get back the signal. If you give the signal to the channel which has the path loss, and then at the other end we are trying to find it out. Okay, so with this small introduction, the program will be executed, and you can see that if we give a transmit power of some dB, how much? Just 20 dB, and the gain is 2, right? Generally gain will be 1, but if you have a longer aperture of your antenna, you can increase it also, right? So if it is 2, and the receive antenna gain is also 2 pattern. So if you assume that similar type of antenna is there on the receiver, you can take 2 and 2, or you can take 1 and 1. Okay. So enter the frequency of operation. What is the link frequency? If you try to give, if I give 1.5 gigahertz or 1200 megahertz or something like that, you can see the losses, how much it be generated, and so on. And system bandwidth you have to give it. So system bandwidth also should be equal to the frequency bandwidth. Otherwise, there will be too much of losses. You can just change that to 100, and you can. And if you change it to 1200 to some 1100 or 1000, so you can see the capacity decrease and all. And the channel is a constant channel. We have to change the channels also for different environments. If you take a standard 20 dB or 20 log something, you will get a standard channel. If the channel is a fluctuating channel, then you get a different values. Okay, we have taken only AWN, it will be constant for all the frequencies. Okay, so you can just have a understanding. The code is given to you. Just try to spend some time on changing the channels also. And if you can incorporate that channel, remove the channel and put other channels, what you are. And now you can run other codes also. We have given you a set of codes, right? You can just run those things up. Or you can keep it for some time until they complete.
How to invoke that Scilab application?
User can keep Scilab, how to activate the Scilab. No, no, you just run it once. It is like you have to click on the file, this one, and open it again. Close this one. Close. Now you open that file. So it automatically opens, right? This is the Scilab environment only.
So from the beginning.
Yeah. You go to the bin. You pick up it.
Class LCW Silex.
So you go to the Scilab directory where it has been installed, right? And in that directory, go to the bin directory, subdirectory, and in the bin directory, you can open it Silex, and automatically you go into the environment window where you can open the file, whatever file you want it.
And you can go.
Yeah. You can pick up the file where you have written the experiments, the mobile experiments, and you can just try to pick up the file and run it. Right? There are set of programs which are there, which you can run all the programs, and this is one satellite link program. So I repeat it again. So the Scilab where it is installed, you go to that folder, and once you enter that folder, there is a subfolder called bin. Okay, go to the subfolder .bin, and in that you have Silex, so you can just open that one. Automatically the Scilab environment will be open. So you connect to the directory where your folder, your programs are there, and then run the code over there. Pick up the codes. You have different types of channel allocation, estimation of BR for differential modulation. You have estimation of receive bit error energy, and there is some example of bit error. Okay. The multi-path pathless models are there. So there is exam lab 1 and 2 also you are doing. Okay. So these models you can run it and see it. Okay. And there is a help directory also available to you. If you go to the Scilab site, there are some codes available for you, which you can use it for other subjects also. Not only for this, you have for other subjects also. We have a lot of add-ons are there, because we have written 2 books for it. One is digital logic design and other is vision theory. So the codes are available over there where you can run it and see. Right? So the 2 books, what we have written is also available on the Scilab textbook version. So there are most of the textbooks have been converted into Scilab companions, and you can easily use them for your applications also. Okay, thank you. You can continue working.